recording. Sorry guys, I was a bit late today. Something ran over time and yeah, so I didn't make it in time. Okay. So the last physics question I did was force constant as well as the extension of the spring. We completed all of that. That was from the new syllabus 23.5.2. So this was supposed to be, I think, year 9 combined science physics or year 10 combined science physics. It's stated in the syllabus that this is required and you should be rearranging the stuff and proving that it's elastic. Elastic means that it will follow the trend and therefore y is equal to mx plus c. Your y-intercept is 0. Your gradient is k. Your x-axis is the x there. That's your, what is this? Extensions. That doesn't seem right. Extension against lot. So that is f equal to kx. So x equal to f over k. Is that right? So now this one become my y-axis. And we are saying that the force is the x-axis here. Therefore, 1 over k is the gradient. This is as stated in your mathematics. Y is equal to mx plus c. Stated in mathematics syllabus. Y equal to mx plus c. Y is equal to 1 over k is the gradient. The x is the force because force on the x-axis. Extension, which is the extension there on the y-axis there. Anyway, I move on to the next physics question. And the next physics question is on this electricity as well as radioactive sources. I do believe that electricity was a year 10 or probably year 11 concept. I don't teach physics directly, but I know it's in the syllabus definitely. So this shorter end there, this means it's negative. This is longer end. So this is the positive terminal. So again, there's positive and there's negative. The positive is connected to the positive plate. The negative is connected to the negative plate. This is your radioactive source there. Emission from the radioactive source give a charge to the air particles. Your radioactive source give a charge to the air particles. The charged air particle then move towards the charged plate. Identify the energy stored in the radioactive source. They said just tick one box. So this word radioactive is a physics word. I don't know. Let me ask Nakildin, what is going to be the energy stored in a radioactive material, Nakildin?
Nuclear.
It's got to be nuclear. So this word radioactive means unstable nucleus. In chemistry, you will have learned that the nucleus contains protons and also neutrons. But then when you go up in atomic number meaning proton number, when that atomic proton number increases, there are more neutrons as well. There are more protons, there are more neutrons, and now it becomes unstable. Think about your hand. Your hand can only fit so many marbles, and then when there are too many marbles, your hand cannot carry anymore. Then it becomes unstable. Then something will fall off, and that happens inside the nucleus. That is to do with nuclear physics. That's got nothing to do with chemistry because chemistry is to do with the electrons on the outside. We don't care too much about the nucleus. Nuclear energy, radioactive sources, unstable nuclei, unstable nucleus. That's nuclear physics then. Now identify the energy gained by the air particles. So what should this be then? Tick one box. So the nuclear source, they will decay and then they give out energy. What sort of energy do they give out then, Chayan?
Kinetic energy.
Gained by the air particles. I think you're correct because this is gained by the air particles. So the air particles will move faster. So they're already gaseous and then they move faster. And when they move faster, this is to do with motion, something called kinetic particle theory. It's basically your first topic in chemistry. It's to do with motion. It's to do with your kinetic energy, which is to do with the more you move, the more kinetic energy you have. So there's kinetic energy there. Now you're going to store it inside the battery here. So Mirza, what do you think is the type of energy stored inside the battery? So you have a battery there. So you're going to store it inside the battery. So what is the energy stored inside the battery?
Store energy.
Yeah, it's called tick one box. The options are in front of you. So which one did you say? You said sound
Electrical.
energy. Did you say sound energy?
No.
Oh, okay, electrical. So it is an electric. I haven't checked the marking scheme. Let me check quickly. Okay, why do I think it's chemical energy? Because usually chemical battery should be chemical energy. I should really check this, yeah? Just in case I don't want to get this wrong. This is question 12. Oh, yeah, correct. It's electrical energy. Okay, so it is the electrical energy. Now for part B, this is the kind of calculations which a lot of students struggle. You will see that this is 3 marks and this is 2 marks. You can get 5 marks easily if you know your formula. And how come you don't know the formula when the syllabus for physics did mention all the formula that you're supposed to know? If I were you, I would write down in a notebook, like a personal notebook, all the formulas stated in the syllabus. And you should know about this because you can download the 5129 syllabus. Make sure it's from 2023 onwards. That will start from June this year already, the new syllabus, yeah? This EMF, what does EMF stand for, Balkis? What is the long name for EMF? Is Balkis there?
Electric, magnetic, electric.
Nope. It's called electromotive force. Have you done this topic yet, guys? You should have finished this topic, I think. This should be a year 10, I do believe. But I could be wrong. It could be a year 11 topic as well, yeah? Now, what do we have? Current. So we have time. This is 1 hour. Current, Q is equal to IT. Q is charge. I is current. T is time. Okay. Usually when you write the word key, you don't label all this because you're supposed to go in knowing already. Now the charge there, the unit is coulomb. The C there represent coulomb. So 4.1 coulomb is the charge. The current is in ampere. So A there is in ampere, A-M-P-E-R-E. You will measure ampere or current in ampere using ammeter. Ammeter is the apparatus. Ampere is the unit. And time there has to be in seconds. It must be in seconds. There's the problem there. This is 1 hour. So how do you convert hour to second? First of all, convert the hour to minute first. So how many hours is there in 1 minute? How many minutes are there in 1 hour? Sorry.
60.
Okay, and now 1 minute, how many seconds is there in 1 minute? Yes, Nakyudin?
3,600.
Okay, well, 1 minute is 60 seconds. Therefore, 1 hour is equal to 60 minutes times 60. Convert that to seconds. So that's 3,600 seconds. You must always have a calculator next to you so that you can do this easily. So what I'm going to do is, before I put in the value, I should really think about Q equal to IT. I want the I. So this is I multiplied by T. So put the I on one side, move the T to the other side. I multiplied by T. So to move T to the other side, it becomes Q over I. Oh, sorry, Q over T. But be aware that this time has to be in second. The Q is the charge in coulomb. So what I do next is I just put in the value. And that's it, really. Just put in the value. Okay, I always encourage to rearrange first. So there is 4.1 coulomb, but the time is 3,600 seconds because in this formula, the time must be in seconds. So put in your calculator and you should be able to get the final answer. And this one is 1.14 times 10 to the minus 3 ampere there. Okay, hopefully that it's all right for people. Now, I don't think that should be the final answer because you see this value, 9.0. One significant figure, two significant figures. This is called two significant figures. Now you look at 4.1 Coulomb, one significant figure, two significant figures. So it means that your final answer should be given to two significant figures based on the data in the question. So it's 1.1 times 10 to the minus 3 ampere. Last bit is a show that question. Show that means this is the answer. This is the answer. So, gotta get the answer. Do not randomly multiply. You're supposed to go in knowing the formula. Okay, the syllabus show you everything. This is power. So we know that power equal to work done times time. Okay, is it work done times time? Okay, so work done there is your IV multiplied by T. So P is equal to IVT. Okay, so this time has to be in second. This time has to be in second. So I do have my current 1.1 times 10 to the minus 3 ampere. My EMF is 9.0. My time in second is 3,600. So 1.1 times 10 to the minus 3 times 9.0 times 3,600. I don't get that answer. Did I do something wrong? Equal to IVT. Hang on. How come I don't get the answer? I must have messed up. Oh my goodness me. Did I mess up? Let's see. Oops. I got it wrong. P equal to IV. See, that's why I don't teach physics, okay? So P equal to IV. P equal to IV. So I should get 1 mark if I do IV correctly. So 1.0 times 1.1 times 10 to the minus 3. So there is current multiplied by the EMF, which is 9.0 volt. And then, what is joule per second? Joule per second, power times time. That doesn't make sense. What's the next equation I need? Blah, blah, blah. So 1.1 times 10 to the minus 3 times 9. They give me 9.9 times 10 to the minus 3. Power. Oh yeah, that is the power, isn't it? So that is in 1 hour. Just give me a minute, yeah. I think power is equal to energy is IVT. Energy equal to power times time. They're not asking us for energy. So I guess we just need the power. So this thing is around 10 times 10 to the minus 3. So this is equal to 1.0 times 10 to the minus 2 watts. So this thing can be converted to 10. On your indices from Maths D, you can move these to the front by 1, and you will multiply by 10. So 10 to the minus 3 times 10 gives you 10 to the minus 2. Okay, and that's it ready for that 8 marks. So it's just show that question. I guess the most important thing is P equal to I times V there. All right, so moving on to the next one. So that's biology. So I skip biology. I already finished the chemistry. And now this is another physics question. So this is about charged particle. So first of all, this is at rest. At rest means not moving at all. Smooth insulating surface, so no friction whatsoever. So you have equal and opposite charge. So here you have negative charge. You have 1, 2, 3, 4. So if I have plus is equal and opposite. Well, it's opposite at the moment. So positive attract negative. But then at the same time, I have 4 of the minus 1. I must have 4 of the plus 1. Because minus 1, minus 1, minus 1, minus 1, cancel out plus 1, plus 1, plus 1, plus 1. Because they are attracted, because they're oppositely charged, but they are not moving whatsoever because you have equal number of charges on both sides. They're just attracted, equal and opposite, but they are at rest because they are not moving. They're just attracted already. Okay, that's why it's equal and opposite there. So I have to draw, for that 1 mark, you have to draw 4 of the positive charge so that the charge are opposite, but also equal number. 4 of the minus 1, 4 of the plus 1. Now the next bit is a longer question. This is deduce. Deduce the charge. Deduce means tell the charge, state the charge, state the charge. That's the first part. And then explain why the sphere move apart. When two things move apart, and these are charged sphere, they move apart mean they repel. This keyword is called repel. You repel because you have the same charges. So like charges or positive repel positive, negative repel negative. Now just now you have minus, 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 minus according to this, and you also have plus, 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 plus. So now what happened is, how come they repel now? When you put object C near sphere A. Sphere A is attracted to C. That is what we could see. A is attracted to C. So A is attracted to C. A is negatively charged. What can you comment about object C here, Marissa? Balkis, let's do Balkis. What can you comment about this charge object C here? What charge is C, Balkis?
It's positive.
It has to be positive, and that's the first thing we can say. We can say that object C is positively charged. Now, why do we say it's positively charged? Because C is, well, A is attracted to C, or C is attracted to A. So A is attracted to oppositely charged C. But be careful, because just now we also said opposite charge should attract. Then why is it possible that C would attract A when A already attracted B just now? So what can you comment on this, Balkis? Which attraction is stronger, A and C or A and B?
A and C.
Okay, so A and C must be stronger attraction, because if A and B is stronger attraction, then no way the A will move towards the C. The A was attracted to B. Now there's a new attraction. So the attraction between A and C is stronger. Now, this is 4 of the minus 1, attract 4 of the plus 1. Can you suggest how many of the plus must I have? If I have 4 of the positive, 4 versus 4, that means if I have plus, 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 I have 4 of the plus 1 versus 4 of the plus 1. There should be no winner in the tug of war. There should be no winner. But based on what Balkis said, this must be attracted more to A compared to A and B. That's why I'm pulling it closer to me. So is it still 4 of the positive charge, or is it more positive, or is it less positive compared to B? What do you think, Chaya?
It's more positive.
Okay, so C must contain more positive charges than B, because if I have the same number of positive charges B, I will attract them by the same amount. I will not pull it just because there is no winner. Both are pulling the same way. So why should this be going towards this? It must mean that I have slightly more inside. I have slightly more inside here that actually make me more attracted to C compared to B. So I must say that therefore more positive charge, more plus or positive charges inside in C than in B. Therefore, A is more attracted to C than B. Okay, now explain why the spheres move apart. Okay, that one I'm not so sure. So we talk about repulsion. Yes, yes, yes. What else do we need to talk about? Light charges repel. So what do they say about light charges repel? I don't quite get the last bit there in the marking scheme, but we're just going to write it down anyway. So they mentioned that, opposite charges attract, which is quite common thing to say. Opposite charges attract each other, they come toward each other, and like charges, or positive repel positive, negative repel negative. Okay, hopefully that makes sense to you. Doesn't quite make sense to me, the last point there, I mean, in the context of this example, but that's what the marking scheme said for the last point. Okay, So that's how you get like, a couple of points. The first part, we already deduce the charge, explaining why it's worth 2 marks. This is worth 1 mark. And then in terms of explanation, it's like 2 marks there. Do not write like 1-line answer. You see 3 marks. The objective should be writing as much information as possible that is relevant to the actual questions. Yeah. So on to the next one. What's the next physics question? Okay, this is on magnetism. Have you guys learned magnetism yet? Has, I don't know, 11A already learned magnetism? Is this still in the syllabus? Can you guys confirm? Have you learned anything called magnetism in combined science? Anyone can confirm? Okay, let me just double check your syllabus, yeah? What about 11B? Have you done magnetism in 11B?
And it's still in progress.
Oh, so it is a topic in the syllabus, is it?
It should be.
It should be. Let me check. Magnetic force, electromagnetic force, wave, gamma ray. Magnetism. No, it's not. It's not. I'm just gonna share something else with you guys. Let me share. Okay. Do you see this PDF? Are you guys seeing the PDF at the moment? So there is this thing, changes to this syllabus, combined science 5129. You guys are seeing the syllabus, right? Correct? On the screen? Hello? Are you guys seeing the syllabus on your screen?
Yes.
Yes.
Okay, that's good then. All right. So it said changes to this syllabus for 2023, topics added. So these are new topics. For chemistry, we did exo, endo, so that is new. Rate of reaction is new. All those explaining concentrations, pressure, surface area, catalyst, redox, oxidation, reduction. Topics removed. So that means if you see this particular type of questions, that means it's no longer in the syllabus. Asexual reproduction, so that one, those are biology. For chemistry, this one are removed already, so no more. For physics, magnetism and electromagnetic induction is no longer in the syllabus. So this particular question 18 is no longer in the syllabus. So I'm going to skip it totally. Topics removed for the 2023 syllabus already. So you must be very careful about the thing, okay? Chayan, are you sure you are doing, when you say in progress, you mean you're still being taught on magnetism?
We haven't learned about it.
You haven't learned about it because it's no longer in the syllabus. Okay, this is no longer in the 2023 syllabus. Okay, so I just wanted to double check. I just want to show you that there are some stuff that are no longer in the syllabus. I am well aware of the chemistry bit, but I am not very familiar with the biology and the physics bit. That's why I wanted you to actually go through them and make sure that you know how to use the syllabus. Okay, I do believe that is the last physics question. So what I'm going to do is I'm going to go through as many of the bio questions as I can, but my biology is not very reliable. Yeah, okay, so let's go through some of the biology question there. Which is the first biology questions. I did go through this bio question last time, so that one is okay. Where's the next biology question? You see, this was food chains. I think food chain is no longer, just now I show you, food chain and food web is no longer in the syllabus. Food chain and food web. This is stated in the syllabus, removed from syllabus. Remove from syllabus. And you can check it in the syllabus document. I can send you the PDF letter, but what you do with it is really up to you. This is on page how many? Just check. Page 57. Page 57, 2023 syllabus. It's mentioned specifically that food chain and food web has been removed from the syllabus. Okay. All right. I did go through it last week. I didn't remember to check the syllabus first. That one was okay. Okay, this is another biology question. But I'm pretty sure heart rate and exercising is still in the syllabus. That one I'm pretty sure of, yeah. So in the investigation, three male students measure their heart rate. This is about heart rate. When they are resting, so that means they are not doing exercises, immediately after exercise. So when you do it after exercise, your heart rate, you expect to be much higher because you have just done a lot of exercise. So what we can say is more active kind of respiration because your body needs more oxygen. You need more oxygen. You take in more oxygen so that you can breathe. You can breathe more so that you don't run out of breath. You run out of breath, your heart pumps a lot faster because you don't have enough oxygen to sustain your heart pumping due to heavy exercising. You can see the unbolted one is resting. Resting heart rate is always smaller than exercise heart rate. After exercise, all of this one, this, and this is always higher than resting. That's the first thing you can notice from a graph. This is called a bar graph. This is not a curve or a line graph. This is simply called a bar graph. This is in your maths syllabus. This is called a bar graph. The y-axis show you the value. These are called level, and this is the unit. This is the y-axis, level, vertical axis, level, and there's the unit. And this is, of course, the category. So this is basically a person number 1, 2, and 3, and this is just the gender. So they have combined together 1, 2, and 3 as female, 4, 5, 6 as male, or you could do male first and then female, as long as you kind of group them together so that it's quite easy for you to do the comparison. So I hope from your diagram, state the heart rate, state. So it's not explaining, just state the heart rate, female 2. So this is female, this is 2, when resting, okay? From your diagram, what do you read, Mirza?
65.
65. So female 2 when resting. That one is correct because that's halfway. That is halfway in between 60 and 70. Always read the one before. Always read the one after. This is exactly halfway. This is 65 beats per minute. Okay. State which student has the largest increase in heart rate. Be careful with this. It says increase in heart rate. It's not heart rate. They are not looking at the highest heart rate. They are looking for the highest increase. So this means this is the difference. This is the difference between without exercising and after exercising. So what do you get, Cheyan, from your diagram?
Student C.
There is no student C. There is only 1, 2, 3, 4, 5, 6.
Student 3.
Okay, so I mean, without doing actual calculation, this is what I have highlighted on the paper. So you can see roughly, I mean, just seeing the difference between the without exercising and after exercising, this is the biggest among them all. You can use your hand to kind of follow the gap, the gap between the, it's hard to tell, Cheyan. There is another option, so we might have to check. I think it has got to be this, number 3 or number 5. It's either number 3 or number 5. This thing and this thing looks to be the biggest. So what I'm going to do is I'm going to quickly check. This one is 145 because this is 145. If you check 145 minus 80, you get 65. I'm just going to double check because, sometimes our eye play a trick on us. This is 130 minus, you should have calculator. This is 60. This is 70. So you're right. So it is student number 3, but 70 and 65 very close. So sometimes you need to, double check just to make sure that you don't mess up. It's going to be student number 3. So student number 3 has the largest increase in heart rate there. Now suggest one way in which this investigation can be changed. So this is part of paper 3 now. It was in paper 2, but now it's in paper 3 because it's to do with practical study. You want to make it more reliable. What does reliable mean to you, Nakyudin? What does reliable mean to you?
Lebih tepat kan ya.
Tepat is accurate. So what is reliable, Mirza? When someone is reliable, what can you say, Mirza? Is Mirza still there? Okay. Balkis, what is meant by, oh, Mirza, yeah. Okay. What is meant by reliable, Mirza? It's probably lagging very badly on this side. Is it coming? Okay, it's probably not coming. Balkis, what is meant by reliable?
More valid.
More valid, okay. More valid, reliable, that means consistent result. So if you ask someone else to do the exact same thing, they should get the exact same result. So this is meant by consistent results, yeah, okay. So one way, so how can you change this investigation? So this is nothing to do with control and stuff. It's just saying that, usually reliable, okay? I can tell you, in an experiment, if you want to make something more reliable, usually you do it one more time. It's called repeating one more time, and then you can take average. It's like you measure mass. Why don't you measure again? Because if you are using the exact same thing and you measure a second time, the reading should be similar. That means you're getting consistent result. It might not be exactly the same, but it will be similar. Like let's say 20.11 gram. The next time you weigh is 20.12 gram. So what can you do? You can average them. So that way, by repeating it one more time, by collecting the result one more time, then you can take the average, it will make the result more reliable. That is usually how we make result more reliable in the lab. It's not saying it's more accurate. So Nakyudin earlier just now said lebih tepat, but that is accuracy. Accuracy depends on the apparatus. To use better apparatus, I can talk about 20.110 gram. Now that is accuracy because I use higher decimal places. The more decimal place, the mass balance, the more expensive this is. This is more accurate. More accurate. So more accurate results use more accurate apparatus. But the more accurate the apparatus, the more expensive it becomes. So accuracy is different from reliability. Reliability in Malay is keboleh percayaan. So that means if someone else do your result, they should get similar result. So to do that, we do it a couple of times and we can average it. So the idea is repeat the experiment, repeat the investigation for each student, or you can repeat the result for each student. Not really result. Repeat the result or experiments. Repeat the investigation or experiments for each student. And then what you can do is you have to talk about average the result, and then average the heart rate for each experiment for each student, essentially. Okay, so part C is the actual biology bit. So why does the heart rate increase during exercise? So you should have 3 points. So there are 3 marks there. They should have 3 points. So I don't know. Mirza can go ahead. So what are the kind of points you know? Why does the heart rate increase during exercise? Any thought, Mirza? Unless this problem is probably choppy connection again. How about you, Balkis? Give me the first point.
To provide more oxygen for the body.
Okay, so to provide or to pump more oxygen around the body, Okay, why does it want to do this, Balkis? Keep on continuing. Why does it want to do this? Why do you think you need more oxygen? What is the purpose of oxygen?
Blood,
What is okay? What does your blood do? Why do we need oxygen? Okay, why do we need oxygen in the body? That's the question. Why do we need oxygen in the body?
to breathe.
To breathe. Okay, why do we breathe oxygen? That's the question. Why do we breathe oxygen? What is the purpose of breathing oxygen? What do you think, Nakyude? What is the purpose of breathing in oxygen? Why don't we breathe in carbon dioxide?
Supaya senang napas.
I know. What is the purpose of oxygen in our body? You should have done this in biology. It's oxygen plus water. Is it oxygen plus water? No, oxygen plus glucose. Give you carbon dioxide and water.
Respiration.
Yeah, so by writing these equations, you need to know this is respiration. When you say your cells, your body, your muscles need more oxygen, but why? But if you just have oxygen, if you don't eat any food to provide you glucose, you're not going to burn the calorie. Burning calorie. Every single sweet stuff that you eat is going to get broken down into glucose, and that is going to provide you energy. And then this is combustion. Combustion means you're burning the glucose inside the body. When you exercise, the body gets a lot hotter because it releases a lot of energy. It's an exothermic reaction. So respiration activity increases during exercise. But why? Because to provide more energy. Because it's an exothermic reaction. So it's like burning calories is an exothermic reaction. I say about burning calories because that is burning food inside your body. Burning the glucose inside the body is exothermic. Your body feels hot, but at the same time, it also provides more energy for exercise activity. It's like you need that energy to sustain your exercise activity lah. Okay? And as a result of it, when you do respiration, you also produce carbon dioxide. So we produce more carbon dioxide, we make more carbon dioxide, and your body doesn't want that carbon dioxide to stay around. So what will your blood do? Your blood will try to pump out more carbon dioxide. So the heart works a lot harder to try and pump out the extra CO2 also. Okay, is my Sarah with you, Marquis? Is my Sarah with you, Marquis?
No.
Okay, all right, no worries. Okay, but yeah, I mean that is pretty much everything I can tell you. But I can show you what it says in the marking scheme now. You don't really have marking scheme in the actual thing lah. But let me just share my screen with you. So you should be able to see the thing now. Okay. So marking scheme are useless to you unless you can cheat inside the exam. So there are 3 marks in the marking scheme here, 3 marks. So it means that you can choose any 3. So what I've done is I try to make it a coherent story that makes sense, a logical story that makes sense. So it was all about respiration. Respiration is all about burning food, burning calories in the body. They did not mention about the equation. Why should I include it? Because it's easier to think about the equation because you know photosynthesis. You know photosynthesis, and that is why we are doing the opposite of photosynthesis, which is called respiration. So when I have photosynthesis, because they can ask you on photosynthesis also, why is it not sharing? Okay. All right, so in photosynthesis is the opposite of respiration. It's the totally opposite of respiration. This is by plants. And plants need photosynthesis to make food. So a plant take in the carbon dioxide that we breathe out, plus water, because you need to water your plant, and then you will produce oxygen gas, but you will also produce glucose, which is your source of energy, your source of food. But plants doesn't do that on its own. You need sunlight, and you also need chlorophyll. So this is photosynthesis, and this is the opposite of respiration. So respiration burns calorie. Respiration burns calories, and then it releases energy. That is how we get energy to talk, to move, to do work. So respiration is exothermic. Now, respiration is going from this side, going to this side to produce carbon dioxide and water. That also means, therefore, photosynthesis, which is the opposite way around, is endothermic. As we are going the opposite way around, we are not going to release energy. We're going to absorb energy from the surrounding, such as the sun.
Mama bagi aku. Aku tahu.
You all right? Okay. So there was the sunlight there that provide you the energy for photosynthesis. Okay. That's the end of that biology question there. I think we can just move on to the next one. I'm going to skip that, okay? I am not very good at explaining this particular topic. So you guys can ask your biology teacher to go through this particular topic with you. Okay. Yep, this one I think I'm not very good with this. I'm not very good with this section. You might have to go through it on your own. This is about 3 correct statements about the elementary kernel. I just don't remember anything at all anymore. Okay. But this one I can do. This one I can do. So this one is amylase. Amylase is enzyme. Amylase is enzyme, I think. Is it enzyme? Yeah, it is enzyme. Okay. This is acid inside the stomach. So the stomach is hydrochloric acid. So the stomach is around pH 1 or pH 2. Strong acid, yeah? Okay. So what is the effect of it? So the acid will denature. Denature basically means it destroys the shape, okay, of the enzyme. When it denature the enzyme, therefore making the enzyme useless. So that means your enzyme will die, your enzyme become useless, your enzyme cannot break down the food anymore. So basically, it destroys the enzyme. The word is called denature. You should be able to use this word. It is stated in the syllabus. I'm just going to tell you very quickly where from the syllabus it is from. If I just open up my syllabus, you should really... Oh, the word denature is no longer in the syllabus. Okay, I'm not sure whether you guys talk about denaturation, but basically it destroys the enzyme. If you don't like the word denature, you can use the word destroy. So the acid makes the enzyme useless because it destroys the enzyme, and therefore it can't work anymore. I think that's pretty much everything because this was excluded from the syllabus. So we finished with the paper 2 already. I'll advise you again when you go through the other questions, make sure you know whether it is in the syllabus or not. Just be careful, yeah? Do have a printout of what is in the syllabus and do go through the topics, especially the one that your other teacher hasn't gone through as well. All right. Now, what I'm going to quickly go through now is to show you this thing called examiner report. Okay. I remember I showed you this examiner report last time. I forgot who was in and who was out. But examiner report is very important because it shows you what the key message from the people who mark your paper, whether they like your work or not. Do not write in pencil. Only graph and only diagram and sketches should be done in pencil. Everything else do in ink, including working. There's some of you who love to do working in pencil. It's useless. It's waste of time. You don't ever do that for Cambridge exam. Okay? Using all the correct symbols, such as just now, when we did here, we go to IT, correct symbol also must have the correct units. So that is physics and chemistry bit. We already did most of these. And where was it? Today, the question I covered was about, majority of candidates can read from the bar chart. And then you see they bolded this increase in heart rate because they say a lot of students thought that is the highest heart rate. Earlier, I mentioned this specifically because I know this is very common, commonly misunderstood English. You read one time, you will miss it. I repeat again, you read one time, you miss it. Circle, underline, whatever it takes. If you refuse to change, you will fail in your June exam. And the result, when it comes out in August or September, it will be the same thing for your qualifying. It will be the same thing for your final O-level exam in October as well. If you don't circle, underline, we are not first language speakers, so it's always going to be a bit more difficult for us. More so for some people who cannot speak English very well, who cannot read very well. So, faham, okay lah. Only the strongest responses, only the best answer said that you need to repeat and then average calculated. This is very common in paper 3. Back then, there was no paper 3. Now there is practical components. So it's very common that we have to increase the sample size. So rather than having 6 students, you can have more students. Because if I say, I want to compare 11A performance, but if 11A is only 5 students, 1 student is 20%, so it's not that accurate. But if I say I'll compare 11A throughout the whole Brunei, then I have a lot more students, the result is more reliable when you have a lot more people. Or you can repeat the experiment using the same number of students, like 5 students, but I repeat, I keep on giving tests like 5 or 6 times, and then I see their progress. Consistently, keep on being U. Never ever improve to a C. So that means the final result should be a U. Okay? If consistently A, B, so the final result should be A or B lah, consistent. Okay? Many responses were vague. Vague means kabur, okay? Like not very clear, okay? Not very clear. And you're supposed to talk about this word respiration. Earlier, I think Malkis was struggling for this word. Nafiuddin didn't even get to that word, which is a bit scary, okay? What else can I tell you? Radioactive source, that was all right. Many people could do this, many people could do this. Only a small proportion of candidates, very few people, not a lot of students could use Q equal to IT. A lot of people don't know this formula. Some candidates have difficulty rearranging. This is a primary school algebra. It's like y equal to 3, how do I say it? 6 equal to 3x. So what is x? This is 3 times x. So move the 3 to the other side. It becomes 6 divided by 3. Now you have f equal to kx. So k equal to f over x. This was using number. This was using algebra. It was q equal to IT. So find I, which is q over t. If you mess up your simple rearrangement, you will fail your mathematics and also your combined science. Okay? It's the same when you go to Polytechnic or IBTE. You will fail there if you don't fail in O-level first. Okay? Blah, blah, blah. So this is basically calculating power. I had a bit of problem just now. So it's this formula P equal to IV. Power equal to current times voltage. I skipped this question just now, the asexual and sexual reproduction. What else? This was about counting the equal and opposite charges. I will show you the question that we went through. These are the comments that the examiner gave. So majority, a lot of people recognize that. So a lot of people get the marks. This was the 3 marks question. This was the 3 mark question. Okay, even I was a bit skeptical about why the sphere move apart, but you are supposed to say, unlike charges attract, like charges repel. So they are saying that basically when the like charges come from the other side, so you have plus, plus, and you have minus, minus, this will attract. But then because you have, earlier you also have plus and plus, so this attract this attract this, but now I have stronger attraction from here, it moves towards this side, but plus and plus, same charges, this will move away, they will get repelled. This is basically an important statement. I think it came out in your February 2023 exam, paper 2 as well. All right. And I think that's pretty much it because this one was out of syllabus already. So I did skip these questions. This is out of 2023 syllabus. It was on magnetism. I showed you earlier. The syllabus is out. No point of you spending time on it. Okay. Now, I will spend the next 10 minutes just quickly going through whatever multiple choice question I can do. But preferably, I don't do the multiple choice. Preferably, you will complete the rest and we will discuss it in the next session, the rest of it. But I'll go through what I can and see where people are. You have 1 minute for every MCQ. That's one thing I can tell you. If you are doing IGCSE, such as school like ISB and the rest of the world, their multiple choice is not 1 hour. Their multiple choice is 45 minutes. O-level get extra time because O-level caters for Asian students, Southeast Asian or East Asian students. They are saying the English is not our first language. I give you extra time. I give you extra time so you can read better, so you can circle, so you can underline and do them correctly. I give you extra time and you ended up guessing the answer and not doing things properly. It's a waste of extra time. Okay? Supposed to go in with the calculator and stuff, yeah? Let's skip all the biology first. I leave you to do the biology yourself. I'll go through the chemistry side, which is question number 14. Magnesium plus acid. This is in year 9. Year 9, chemical equation notes. It was during home-based learning. The people who are here today, some of you were asleep during the home-based learning. I remember I had to call someone up to wake you up. But this one was also in year 10, acid, base, and salt. Let me just look up the specific syllabus there. So this is in 18.1.3. 18.1.3. It's in the syllabus. You want to remove the unreacted magnesium. This is metal. Metal is solid. This is a solution. Solution means aqueous. Aqueous basically means not solid. You want to separate solid from aqueous solutions. What do you do here, Nakudin? What method do you use?
Filtration.
Of course, you use filtration, but it comes down to reading the questions and not making any funny mistake. Sometimes they love to ask you to write what is the name of the salt. Okay, and what is the name of the salt that you get? Magnesium plus sulfuric acid, what do you get? Is Cheyenne there?
Magnesium sulfate.
All right, okay. Now, what is the other product that you produce about this? What is the other product that you produce? Metal plus acid. Metal plus acid give you metal salt and another product. What do you get about this?
Hydrogen.
Hydrogen gas is correct. Now, you're supposed to be able to write chemical equation. Mg is magnesium. Nakudin, what's the formula for sulfuric acid? Vocabulary. There are 3 common acids. Nakudin, formula, sulfuric acid. Now, without pressing anything. Nakudin, formula, sulfuric acid. Now, without pressing anything.
H2SO4.
Yep. These are vocabulary, okay? What's the formula for magnesium sulfate, Cheyenne? So magnesium is group 2 ion. What's the formula of magnesium ion when you form salt, Cheyenne? When group 2 metal, they form salt, they want to have fully filled outer shell. What does magnesium do to get to a fully filled outer shell? What do you think, Cheyenne? What would the magnesium do to get to a fully filled outer shell?
It loses 2 electrons.
And it becomes Mg2+. Sulfuric acid, the salt. Salt is when you replace the H+ with the metal cation. So you have 2 of the H+. H2SO4 means H+, H+, and therefore you're left with, mathematically speaking, you're left with 2 minus. So what is the formula of magnesium sulfate, Cheyenne? You have Mg2+, SO4 2 minus. What's the formula for magnesium sulfate, Cheyenne?
Um,
The objective is cancel out the charge. When the charges are exactly the same, that means you're going to have 1:1. Plus 2 added with -2 is +2 minus 2 is 0. Ionic compound has no charge. Now, I know that wasn't the way I did it. I'm going to show you how I did it normally. Normally, we would get the charge down as the value, 2 and 2. And then we would cross multiply. But this is not the simplest ratio. This was from year 9. So I divide both of them by 2 so that I get the simplest ratio. And again, I get the exact same thing. One of these, one of these, MgSO4. Okay, so what's the formula of hydrogen gas? Yes, Malkis, what's the formula of hydrogen gas?
H2.
H2 is correct. There is no hydrogen atom because hydrogen atom is not happy on its own. So what happens is you will want to share electrons. So you have one cross and one dot. Or you can simply draw it without the shell. It's perfectly fine as well. And this question is balanced right now. Now, last question for you. I don't know Mirza is still there or not. Mirza, are you there? Probably lagging really badly. Now, Kyudin, what do you see in this reaction? Metal plus acid. You get magnesium sulfate, you get hydrogen gas. What do you see in this reaction, Kyudin? In paper 3, what do you observe in this reaction, Kyudin? How can you tell when you produce a gas, Kyudin? Because this gas doesn't have color, this gas doesn't have smell. So what makes you say there is a gas? What do you see?
Wait.
What do you see from the reaction that tell you there is a gas? Don't need to Google it. It's a practical question. It's colorless. It's odorless. There is no color. There is no smell. What makes you say there is a gas? You have a solution. You put in the solid. There is a reaction. The reaction doesn't give you color, but what makes you say there is a gas? What do you think, Shayet?
Bubbles are produced.
Yep. There you go, Nakudin. You can tell yourself already, Nakudin, where you are, yeah? Okay. So you get bubbles, that's one thing. And one more thing is you use excess magnesium. That means not all the magnesium is used up. So all the solid will not disappear. You will always get a bit of it at the end, which is what you said, Nakudin. Filter it off, and you should be able to get rid of the solid there. Number 15 here. So water is liquid. And then water vapor is your steam, is gas. And then ice is solid. So we are looking at loose energy. So which are the two states when you lose energy? What do you think about this? Which one is losing energy? So this
Water
is
vapor and liquid.
Water vapor to liquid. That is correct. I mean, water vapor to liquid also will lose energy because that is condensation. But condensation is not stated in the options. So what should you choose then? So I mean, this is correct.
Ice to water vapor.
But ice to water vapor is definitely wrong because your ice particles are closely packed. And now you're very far apart. From very closely packed to very far apart, do you think you're gaining energy or losing energy? So solid to liquid, solid to gas, these two are definitely gaining energy because you go from closely packed. Look, guys, this is your lower secondary science, yeah? So you're closely packed or tightly packed, actually, tightly packed. And then you go to a little bit more space in between. Okay. And then you go to very far apart. So you're going from solid to liquid to gas. So you're gaining energy. You are gaining kinetic energy because you are moving much further apart, which also means if I go backwards, so you are losing energy. Which is why gas to liquid condensation, I say you were correct earlier about this. I say you were correct. I didn't say you were wrong. But I also said that condensation, gas to liquid, was not in the option. So in this kind of question, your objective is put down the state symbol first. This is gas going to solid. C must be the answer because solid going to liquid, moving further apart. How do you move further apart? You gain energy and you move further apart. Solid to gas, move further apart. You gain energy and you move further apart. Liquid to gas, you are boiling. You move further apart. How do you move further apart? You gain energy and you move further apart. This is the only one, gas to solid or, gas to liquid. Those two are the ones that result in losing energy. When you lose the energy to the surrounding, you lose energy to the surrounding. So that is what is called lose energy to surrounding, exothermic, because that is exothermic. If you think about boiling, when you want to boil something, you must supply energy because the particle must absorb that energy from the Bunsen burner. The particle must absorb energy from electricity when you have kettle. So that is your endothermic process there. Last but not least, question 16. That's all the time we have today. So this is about electron. Electron. Proton, P plus. Electron, E minus. So very clearly, zero charge is wrong because we always write E minus, E minus, E minus for a very good reason. So B and B are out. Protons and neutrons, they are in the nucleus. Nucleus is very, very heavy. Nucleus is very, very heavy. Electrons are in the shell. Shell contain electrons. Electrons are very, very light. Very, very light. So the nucleus is heavy. So protons and neutrons are in the nucleus. Nucleus is heavy. Nucleus is the center of an atom. So that is where all the mass is. Mass number is the mass of the heavy stuff. Mass number is proton number of proton, plus the number of neutrons. Electrons, very light. We're looking at electrons, very light, and the charge of electron, -1 then. I did say last time, we remember the mass of electron as 1/2000 because 1/2000 roughly, it's around 0.0005 then. Okay, I'll leave it there for today. You try and complete the rest and we'll discuss more next week, yeah? And I'll have to arrange the time for next week. Sorry I was late today. I will share this PDF shortly and the recorded session should be online for those people who join us a bit later. And the playlist I already shared in the link before. It's unlisted, so you just need to click on it and you should be able to watch whatever you missed from last week or earlier today. Okay, so see you guys tomorrow in school. So